Have you ever wondered why hot air balloons rise into the sky? Or why a can of soda freezes as you open it? These phenomena can be explained by the principles of gas laws. Even from how we breathe, a gas law is present. The gas law were developed toward the end of 18th century by numerous scientists, and each law was respectively named after them. Under standard conditions, all gases show similar behavior. The variation in their behaviors arise when the physical parameters associated with the gas, such as temperature, pressure, and volume, are altered. There are different gas laws, but we are just going to tackle the fundamental gas law, namely Boyle's law, Charles' law, and Avogadro's law.
In this law, temperature and volume are directly proportional and the pressure remains constant. When temperature increases, the gas particles move faster, thus the volume also increases. And if the temperature decreases, thus the volume also decreases. This was discovered by Jacques Alexander Charles, a French mathematician, physicist, and inventor who was born on November 12, 1746. He discovered this thermal expansion of gas known as the Charles law. One example of this is riding a hot air balloon. Hot air balloon pilots turn on or increase the burner's flame to increase the temperature inside the balloon, which makes the balloon fly. This law comes with the formula V1 over T1 is equal to V2 over T2. Here is a sample problem that will enhance our understanding of this law. We can use the Charles law formula to solve this problem. V1, or the initial volume, is equal to 800 ml, while T1, or the initial temperature, is equal to 30 degrees Celsius, while T2, or the final temperature, is equal to 85 degrees Celsius. Substitute this given to our formula. Let us do a cross multiplication to get rid of the denominators. We can divide both sides by 303 Kelvin so we can find the value of V2. 800 ml multiplied by 358 Kelvin over 303 Kelvin is equal to V2. Therefore, the final volume is equal to 945.21 ml.
Boyle's law is another gas law which tells us the relationship of the pressure exerted by a gas and its volume at a constant temperature. Said pressure is inversely proportional to the volume occupied by it. Putting it simply, if you pressurize a gas at a constant temperature, its volume contracts. But when you decrease its pressure, its volume increases. This was coined by chemist and physicist Robert Boyle back in 1662. Have you ever tried to open a bottle of soda for it to turn into a sweet, fizzy mess? To get carbon dioxide into the liquid, the whole bottle should be pressurized with gas. As long as the bottle remains closed, the gas is restricted to a small space. However, when you remove the cap, the available volume increases as the gas hurriedly makes its escape. Meanwhile, its pressure decreases. Its basic mathematical representation is PV is equal to K, where P is pressure, V is volume, and K is a constant. The law may also be used to find the pressure or volume of a system when the temperature is held constant. PIVI is equal to PFVF.
Here's a problem to further understand our concept of this law. We solve this using the Boyle's law equation. To find our final volume, we just derive our equation to V2 is equal to P1 times V1 all over P2. Therefore, to find V2, we have our final volume will be 34.25 milliliters.
Avogadro's law is the relation that states that at the same temperature and pressure, equal volumes of all gases contain the same number of molecules. When we have deflated balloons of the same size and material and inflated both balloons to the same size, these balloons have the same volume. Avogadro's law suggests that they should contain an equal number of gas molecules provided they're at the same temperature and pressure. The law was described by Italian chemist and physicist Amedeo Avogadro in 1811. This can be mathematically expressed as V over N is equals to constant, or V V1 over N1 is equals to V2 over N2, where V is the volume of an ideal gas and N represents the number of gas molecules. Let me give you an example. A good choice is V1 multiplied by N2 is equals to V2 multiplied by N1. Then, substitute the values. That will be 5 liters multiplied by 1.80 moles is equals to V2 multiplied by 0.965 moles. Rewriting to solve for V2 will give you V2 is equals to 5 liters multiplied by 1.80 moles over 0.965 moles. Finally, our answer will be V2 is equals to 9.33 liters.